So sticking with my cutting a card or cutting a face card experiment, another neat trick that I like to do sometimes with my calculator is calculate all of the binomial PDFs simultaneously for a particular number of trials. So if I wanted to know the probability of getting 3 face cards or 4 face cards or 5 face cards, I would have to repetitively type that over and over again. I don't actually have to do that. I can use lists to do that for me. So we'll recall from my previous example that I had an event with 6 trials and a probability of success of 3 over 13. So I'm going to go ahead and make a table. I'll go to Stat and Edit. And in list 1, I'm going to do the number of successes. So 0, 1, 2, 3, 4, 5, and 6 successes. Now for L2, I'm going to go up and highlight L2. I'm going to hit Enter so that I can start to type down here. And I'm going to use my distribution, second function vars. Now, I'm going to use the binomial PDF, and the number of trials is 6 trials. My probability of success, because I'm cutting a face card, is still 3 out of 13. But now my X value is going to be, for each row, I want its number of successes to be the value in L1 beside it. So I'll type second function 1 to pull up L1. And now, I can hit Enter, and you'll see it gives me the probability of each of them. So what's the probability of 0 successes? Well, 20.7%. The probability of 3 successes we saw in a previous video of 11.2%. And then the probability of more than 3 successes we can see is adding up all of these 3 things. Now, this is useful because sometimes you have like a range of numbers that you want to add. Like you want to add this to this. And using a table can be a useful way to get all of those values calculated quickly without having to type the wizard over. I should note, and I've seen this on intersections of graphs a number of times, that people will often write down 1.5 e to the power -4 or some other number that looks very similar to it. As soon as you get into the exponential notation, so 1.5 e to the -4, that's actually really, really close to 0. If you're using trace on your calculator and you see this, it's simply saying that it's either 0 because the scale of your calculator is not nice enough to see that particular number, or it's very, very close to 0. And we can think about this particular case. This would be cutting 6 face cards every single time you cut the deck in those 6 trials. So this is a cool way to use tables to short form some of your work.